All right, let's talk about AI. We hear so much about these brilliant algorithms, right? And these super powerful computers. But what if I told you the single biggest thing that makes or breaks an AI is something we almost never talk about? Yeah, today we're diving into the hidden flaw in AI, and it all comes down to the data it's built on. You've heard the saying, right? Garbage in, garbage out. It's been around forever, since the dawn of computing. But here's the thing. For AI, this isn't just some cute old school saying. It's like a law of physics, and if you ignore it, the consequences can be absolutely massive. So that begs the question, for a machine that's supposed to think, what does garbage even look like? Because this is where it gets really interesting. With regular software, bad data might just cause a simple error message, or maybe the program crashes. Annoying, but that's it. With AI, oh, it's a whole different ballgame. Bad data doesn't just cause a glitch. It gets baked right into the AI's brain, poisoning its entire understanding of the world from day one. Okay, so if we're gonna spot the garbage, we first have to figure out what good data even is. And it turns out it's not just one single thing. Data quality is actually made up of a few different key ingredients, you could say. Every single AI system depends on them. So let's break them down one by one. First up, and this is the big one, accuracy. This is the bedrock, the foundation of everything. It's simple, really. Does the data actually reflect reality? Is it true? And for AI, this is so much more than just getting the numbers right. It means if you're showing it a picture of a cat, it's actually labeled cat. Sounds obvious, right? But if those labels are wrong, the AI learns a lie, plain and simple. Next, we've got completeness. I want you to imagine trying to read a book, but half the pages are torn out. That's exactly what it's like for an AI trying to learn from incomplete data. And those missing pieces, they aren't just harmless empty spots. They can totally mislead the model, making it learn weird, skewed patterns and spit out biased results, all because it's literally not seeing the whole story. All right, then there's consistency. Think about this. New York City. Is that NYC, NYC, or New York? You and I know it's all the same place. But to a machine, nope, those are three totally different things. And when you have little inconsistencies like that, multiplied millions of times across a giant data set, well, it just confuses the heck out of the AI. It makes it almost impossible for it to find the real, meaningful patterns it's looking for. And last but not least, timeliness. This one's huge. The world is always changing, right? So the data needs to keep up. There's this great term for what happens when it doesn't: concept drift. Just imagine an AI trained to predict the stock market using data from, say, before 2020. Now you ask it to predict today's market. What's going to happen? It's going to fail spectacularly. Because the world it learned about, that world doesn't exist anymore. Its understanding has drifted away from reality. Okay, so we know what we're looking for: accuracy, completeness, consistency, timeliness. But how do you actually find the flaws? I mean, how do the pros do it? Well, it's not about just poking around and hoping for the best. It's a really systematic process. You can think of it like taking your data to the doctor for a full checkup. So this checkup, it usually starts broad. First, you've got statistical profiling, where you use automated tools to just scan for anything that looks weird or out of place. Then you zoom in with domain validation. This is where human experts, people who actually know the subject, look at the data and ask, does this even make sense in the real world? And finally, there's a really targeted hunt for hidden dangers, and that's bias detection. You're actively looking for subtle patterns that could cause the AI to be unfair. And here's the most important thing to get about all this. The goal isn't just to find a few mistakes and hit delete. No. The real goal is to get to know your data, to understand its personality, its quirks, its blind spots, before you ever let an AI try to learn from it. And what happens when you do find those flaws? Well, the treatments are actually pretty amazing. We're talking way beyond just simple data cleaning. There are these advanced techniques like intelligent imputation that can smartly fill in the missing puzzle pieces. There's sophisticated outlier detection to find the truly bizarre data points. And get this, there's even data augmentation, where you can literally create brand new realistic data to make your original dataset even better. Okay, theory is one thing. But let's bring this down to earth and see how these challenges actually show up in the real world. Because these aren't just abstract problems for data scientists. They have very specific and sometimes very dangerous consequences, depending on what the AI is trying to do. So just look at this breakdown.
In computer vision, if your annotation accuracy is off, meaning you've just labeled a few images incorrectly, that could lead to a self-driving car literally not recognizing a pedestrian. The stakes are that high. Or take NLP, natural language processing. If your data doesn't have enough diversity, like different kinds of slang or sarcasm, your sentiment analysis tool is just going to be clueless. And recommendation systems? We've all been there. That filter bubble where a streaming service keeps showing you the same type of movie over and over? That's a direct result of biased interaction data.
And what this really shows us is that data quality isn't some generic one-size-fits-all issue. Not at all. Every single AI application has its own unique data quality fingerprint, its own special weak spots that you absolutely have to know about and plan for. I know. This all sounds like a ton of work, right? A lot of technical, nitty-gritty stuff. So you might be asking, why bother? Well, let's zoom out for a second and talk about the payoff. Because investing in good data isn't just some chore for the tech team, it's one of the most important strategic decisions a business can make. Because here's the bottom line. When you get data quality right, the return on that investment, the ROI, is absolutely huge. And you see the benefits everywhere. It really creates this amazing chain reaction. First, boom, your models just work better. They're more accurate, more reliable. Second, because your models are better, you slash your operational risk. Third, your teams can actually build things faster because they're not constantly putting out data-related fires. And finally, in a world with more and more rules about AI, having your data in order means you're ready for regulatory compliance. It's a win-win-win-win. So really, it all comes down to this. Thinking of high-quality data as just another cost on a spreadsheet is a huge mistake. It's not an expense you try to cut, it is the foundation. It's the only thing that all successful, trustworthy, and fair AI is built on. And that leaves us with one last question for you to think about. When you look at the AI systems being built around you, in your company, in your world, you have to ask yourself a very simple question. Is it built on a foundation of solid stone, or is it built on a foundation of sand? Because, make no mistake, the tide is always coming in.